Sweet. All right.
Jake to the lectern, please.
Hi, everyone. So I'm Jake. I work on the application framework team at Atlassian as a senior engineer. And the past, I don't know, it's probably over a year now, which is tragic to think about, my life has been CSS and JS. And how we've had a bit of a journey of adopting the new next generation of CSS and JS at Atlassian, and that's pretty much what I want to talk about today. So first thing on the agenda is what is CSS and JS. So CSS and JS is effectively just a way that you want to write styles inside your JS. And usually as web developers, we want to do that because it's got cool stuff associated with it. It's a simplification, right? You get types, you get all sorts of stuff that's just there. For example, we're using stuff like Parcel, Webpack, those sort of things. CSS was never really designed with all of that in mind, so it's just easier to think about it as JavaScript, right? So if you're using JavaScript nowadays, you're probably using one of these two tools for your CSS in JS. So for example, we've got here style components, and the syntax for that is pretty simple. You're basically just defining some CSS in a string literal. And you can do some cool stuff which you want to do in CSS and JS, right? You have your props, you define a prop color, you can do cool stuff. You're generating CSS at runtime and it's working cool, right? Emotion is very similar. There's a different API in Emotion you might be familiar with as well, where you define the CSS as something that's put on a DOM element. So in this div right here, you're defining some CSS. It's a very similar way, just different way of representing it, right? So I want to talk about the problems that you kind of face when you have this sort of implementation, right? So the basic approach of a traditional CSS and JS library, it basically at runtime, it takes the input, which is usually the result of some function, which is what makes it useful, right? You saw those props that I was showing you earlier. That's only available at runtime, right? So you go and do that, you generate some CSS, that can be pretty expensive. You don't really think about it when you're doing it on a small app. When you get at scale, there's a lot of it. So another thing that happens is with that CSS, you need to put that in a CSS tag, right? So you have your style tag. Different libraries do it different ways, but generally it all comes down to it just eventually gets injected into the DOM. And that can be expensive depending on how the library is set up. I don't want to really go into the details of how that all works, but generally you can just assume that there's going to be some level of expense during the page load or during your application. And finally, once all of that is done, what ends up happening is you get a class name on your element most of the time, and then that class name is what was in that CSS that was generated. So all of this generally runs at runtime, right? And if you're familiar with JavaScript, you know that it's all sent to browsers that vary in performance. So you could end up running this on a MacBook, like your cool dev machine that costs the company millions of dollars, or you're sending it to a 3G Android phone that's probably not going to be able to do any of this, right? So it's all rather expensive. Some runtime code can be removed. Different libraries have different ways of doing it. There's actually Babel plugins that do some stuff, but generally it only patches the problem a little bit. And it all comes down to the core architecture of runtime CSS and JS is runtime, right? So how do we fix that? So one thing that people often do is just ignore it, right? There's other bigger fish to fry sometimes. Your application may have other performance issues that are bigger for you to work on, right? But at Atlassian, that was kind of our approach for a while, and then we kind of realized, oh wow, our CSS and JS is taking up a lot of the user's time. So that's not great. We also considered other approaches as well. So at Atlassian, we have style components and emotion, but we also considered what if we use something that's purely build time? So CSS modules is a relatively new thing that people are starting to use now, where it's effectively you write CSS in a CSS file, crazy idea, right? And then you import that, and then you have some glue in the bundler to do it. So that's cool, and that works, and I definitely recommend that if that works for your dev loop. But we decided that because it's a completely different paradigm, it would be a lot of work to move over, and then we would lose all the benefits of CSS and JS, right? So we didn't want to do that. So our approach was build time, CSS, and JS. So there wasn't really a library at the time when we started the compiled project, so we ended up having to write our own. So generally, compiled was a build time transform. Basically, it's just a Babel plugin, and it traverses files that import the compiled React import, and then it turns it into static CSS. So you can see an example here. It's very familiar syntax, right? It's basically the same thing. It turns our component styles in a CSS prop into something that is relatively build time. So all of that turns into a class name that's generated, and it puts it into a class name in the bundler. So this is all done before it hits the browser. So this is in theory is relatively optimal. So, but you can see here, right, there's a couple of runtime components here. So this is one step we take. So there's a minor runtime that actually makes stuff work and inject the style tags. So the next step is called style sheet extraction, where we go through the entire file tree again, just find all of the CSS, we extract it into a CSS file, and then we remove all of those runtime components because we don't need them. We have a CSS file, and then we inject that in. So we do have this little function here. This is just to make sure that we get the correct values at runtime. This is something that we're going to remove eventually, but it's very small and doesn't have much impact. So we haven't gone that full step yet. But yeah, the limitations. So obviously, because anything dynamic can't be transformed. So if there's something returning a value in a function, you can't know that at build time, right? Because it's code that needs to be run. So it could return something different depending on the time or the different input. So generally, we handle that with CSS variables. But we can't do every scenario because of cases where you're returning something that's more than just a value of a CSS function. So say it's a color, red, you can't do that, but you could just return the color red. That would be fine. So we can't handle those scenarios. But yeah, in general, it's been a really big project for us. But the main problem has been it's a really complicated library. There's a lot of edge cases. Leo was a really good example of this exact problem space, right? There's a lot of edge cases when you are dealing with a parser, because that's effectively what we're doing. So the static evaluation logic, which turns all of that code that you write into stuff that is completely static CSS, that's very complex. So as well as that, maintaining takes effort. So there's been a lot of bugs because it's a really complex application, but also the CSS spec isn't super useful in a lot of cases. If you know a bit about the history of web, browsers generally do some pretty crazy things. The CSS spec doesn't always define and tell the whole story about the problem. So sometimes browsers behave differently and you need to account for that because that's what people expect when they use CSS libraries. In general, we don't have full CSS feature parity for CSS in compiled. This has been a bit of a problem for us because full parity is very, very difficult and not worth it. But when you're migrating an entire company to a new library, full parity makes it much easier, right? But we can't really get that. It's just never going to happen. So getting close has helped a lot, but we need to get over the line by taking other approaches as well. So how do you detect differences when CSS is slightly different? Can you just look at VR tests? Probably, but sometimes you can't, because what about interactions? What about different cases where browsers behave differently? Stuff like that. It's just an unbounded problem space, right? It's different code. So generally the approach we're taking nowadays is when we migrate to compiled, what we're doing is we're trying to migrate stuff in small batches to the compiled library. So we support a lot of this behavior, but the goal is to basically, we're just going to move towards static CSS over time. We're going to take small steps, iterate all of the code at Atlassian as much as we can to be something that compiled we know can handle. So generally, we started at the beginning of trying to absolutely replace style components and emotion. We tried the best we could, but now we're coming at it from the other angle of trying to make it work for our library, not style components and emotion. And the way we're doing that is just stuff like code mods. If you're familiar with that, that's effectively just you write a function, it changes your code to something that you want. Very similar approach to a parser, but you're effectively just transforming. ESLint, we want to make rules and stuff like that that can automatically tell people when they're doing something that we don't want to support, stuff like that. But also the main thing we want to do is just iterate. We want to reduce the amount of scope there is on the page and then just make it work. But yeah, that's pretty much all I want to talk about. You can check out our library at compiledcss in js.com. Yeah, thank you.